Hi, good day to you and welcome to my channel where I tutor you in science for free. The topic in this video will be atomic structure. Without further ado, let's begin. We have to look inside the atom to study the atomic structure. It is made up of 3 subatomic particles that you need to know of, mainly the proton, the neutron, and the electron, and they stay at different parts of the atom and carry different kinds of characteristics. Let's look at it. Firstly, it's the proton. It has a charge of +1 and a relative mass of 1. There's no particular unit for this. Now, in further topics, we will further dive into the significance of this number, this mass number of 1, how they all add up to give a substance its mass. Next will be the neutron. Neutron being a charge of 0 gets its name from there, being a neutral party. Similarly, like the proton, it has a mass of 1. So the proton and the neutron have a mass that is significant enough to be considered as compared to the electron. The electron hangs around on the periphery, the outside of an atom in shells. So for easier understanding and illustration, it's usually drawn in circles, but bear in mind they do not orbit the atom like the moon with the earth. It is hanging around what we call an electron cloud. So this is not too much in this syllabus, but just so you know that they do not orbit, they just hang around in a certain location in a shell. So if you have no idea what's going on, just know that it is on the shell. Okay, the electron, unlike the proton and neutron, have a mass of 1/1840 or 1/2000, around there. You don't have to know the exact number, you just have to know that the mass, as compared to proton and neutron, is very small. It's so small that it is negligible. So we don't take into account the number of electrons to calculate its mass. So what is the meaning of negligible? For example, if you stand on a weighing scale and you pluck off a strand of hair from your head and you drop it outside, you are not going to see an actual change in the weighing scale. That's what it's called. The weight of the strand of hair is negligible to your whole body weight. It's too small to be taken into consideration for purposeful understanding. So similarly, a simple table can be drawn to show the relationship between proton, neutron, and electron. The proton and neutron, because they are in the nucleus of the atom, they are called nucleons. And the number of protons added together with the number of neutrons will be called the nucleon number. And in an atom, because the electron has a charge of -1 and the proton have a charge of +1, the number of electrons and protons have to be the same in an atom. So sometimes in certain scenarios, electrons can be donated or received, then the number of electrons differ from the number of protons. This will become a particle called an ion, which we'll touch on in later chapters. Next, we go on to the proton number. So you can see in a periodic table mentioned in the previous video, there is, in each tile, there is a big number and a small number. The big number will be the mass number, which is also the nucleon number. Remember that in an atom, for the mass, we only consider the proton and the neutron, so we need to consider the nucleon number, which is also the mass number, to show how heavy or how big it is. Okay, and the proton number is the small number on each tile, and you can see that the proton number in the whole periodic table is unique. It's like a class register number. You, in your class, you are assigned that one unique number that represents you. However, for the mass number, the nucleon number, you can see that some of them bear the same. For example, cobalt and nickel. And in each tile, you can see there's only 2 numbers, but there are 3 particles in an atom. How do you deduce how many of each are there in a particular atom? So taking a look at a tile, you can see that, for example, in boron, there is a mass number of 11, which means to say there's 11 protons and neutrons, and 5 here represents the proton number, the number of protons inside. 5 protons, therefore 5 electrons, and because there are 5 protons in the nucleus, the remaining will be neutrons. As a result, you take 11 minus 5, there will be 6. So you take big number minus small number equals to neutron number. So do bear in mind the difference between neutron and nucleon. Next is isotope. Isotopes are the atoms of the same element that contain different numbers of neutrons. So recall that, in an element, they have a specific number of protons, which also gives rise to a specific number of electrons, but the neutrons have no charge, so they can be increased or decreased without the element changing its chemical characteristics. So for example, chlorine, you can see it has a funky mass number of 35.5, and why is that? In a sample of naturally occurring chlorine, there are two most common ones, chlorine 35 and chlorine 37 in this ratio, and so to take an average, it will give you 35.5. And common isotopes like hydrogen are these, with the different number of neutrons like these, carbon, and some other radioactive substances that have a large variety of uses, which you don't have to know any examples of isotopes. You just have to know what is the difference between them and how do you identify them, by the different number of neutrons. And so a lot of talk on protons and neutrons. We now go on to electrons arrangement. In a periodic table, we can see that the first row, the long side of it talks about the number of shells. This is called the period, and the short one is called the group number, which is the valence electron. So if you are confused, just remember that the long side match the long word, short side match the short word. And we go from the top. Let's investigate the atoms starting from the top of the table. So having one shell on the first period and having one valence electron, you have hydrogen. This is how it looks like. And on the first shell, because it's small, they can only house a maximum of 2 electrons. So the next one will be helium, and this is considered a full shell. That's why it's at group 0. And usually people will like to call this as group 8. You don't usually call it 8 because of the helium. It can only house 2 on its valence. Valence means the outermost shell. It cannot house 8, so we call it group 0 instead. And moving on to the next period, there's the second shell that appears, and following the group number, you have 1 lithium, 2 beryllium, 3 boron, 4 carbon, and notice that electrons are added in a opposite direction first. So do note that when you are drawing your atoms, your electronic structure in your assignments, or if you are not clear, you can just follow the north, south, east, west configuration. Next 5 nitrogen, you start again north, south, east, west. 6 oxygen, 7 fluorine, and 8 neon. Then next one, period 3, there are 3 shells now. So group 1, sodium, same north, south, east, west. Magnesium, 2, 3 aluminium, 4 silicon, 5 phosphorus, 6 sulfur, 7 chlorine, and lastly 8 argon. Usually in school, there's only a concern for the first 20, so let's go on to the 4th shell. The first 2 will be on group 1 potassium, group 2 calcium. So you can see that the electronic structure for calcium is 288, and lastly it's 2. And why in chemistry are we so concerned over the valence electrons? Because like an onion, if you want to peel the onion, you start from the outermost shell. So reactions take place on the outermost shell. The outermost shell will give the atom its chemical characteristics, whether is it a metallic substance or a non-metallic substance, and how does it react under certain circumstances. Valence electrons can help us to anticipate the kind of material that we are working with. So if you see a small number of valence electrons, anything less than 4 means going to be metallic, and anything 4 or larger than that, you can predict that it's going to be something non-metallic. And that is all for today. Hope you enjoyed this video. Do give it a like and subscribe, and share it with somebody who needs to see this. And I will catch you in the next video. Bye!